Okay, we are going to apply now what we have learned about pKa to be able to predict what reagent we can choose to perform a reaction. So let's think if I have, for example, this is acetate. And let's say that my problem is to choose a reagent. I need to choose an acid, in this case, that is capable of protonating this ion. So let's do that. And what we're going to use is compare pKa's when I use an acid, a given acid, and see if that works. So this is my base, and I am going to use water as my acid. And we're going to see what are the products. So first, let's draw the arrows, how the proton transfer happens. So the base get the proton, this bond breaks, and then my electrons are going to be assigned to water. Here, water is acting as the acid, and acetate is my base. So here we go now. As a result of the proton transfer, you're going to have acetic acid. So that is my conjugate acid in hydroxide. Hydroxide is my conjugate base. Okay, so I'm going to draw those words here. So conjugate base, conjugate acid. And because my problem is to find the reagent, we're going to use pKa's here to see if this works or not. So the pKa of water as acid is 15.7. pKa of acetic acid is 4.7. And we know the equilibrium is going to be shifted towards the weaker acid and weaker base. And as we see here, this is a larger pKa, so that's the weakest acid. That says the equilibrium is shifted to the reactant. So the acid, water as acid, is not a good option to completely protonate acetate. So that's not going to work. So instead, we're going to choose something else. Let's use, for instance, hydrochloric acid. And this time, I'm going to draw, say, my reaction now. What happens here? Now, hydrochloric acid, and here again, our mechanism will be proton transfer, right? We're getting the protons with the base, this one breaks. And what we're forming here is now acetic acid, same product. And now by deprotonating here, we're going to get chloride ions. Right, so labeling again, that's my base, that's my acid, conjugate acid, conjugate base. And let's look at the pKa and see if this acid now works. Well, pKa of hydrochloric acid is -7. pKa of acetic acid, we have it here, 4.7. So we clearly see that this is larger than this number. So the weaker acid is on the right-hand side. So we predict that this reaction is actually completely shifted to proton. What that says is that this acid works to protonate the acetate. So, and in general then, we're going to be looking, if we have, this is my acetate, my target is that. So I want to look for an acid whose pKa is smaller than this number. So anything that has a pKa, say, below 4.7 is going to work to protonate acetic acid. And this is the explanation, because if the pKa is smaller, then because always the equilibrium is shifted to the weaker acid, we're going to get, say, pKa is smaller here, larger, I'm sorry. So the larger the pKa, the weaker the acid. That's why this works. So here we want to choose an acid with pKa smaller than 4.7 for that reaction to work. We're going to continue doing another example. So that could be easy, a question on a test, asking you, choose between this acid, the one that is going to be able to protonate acetate. And here the answer is water doesn't work, hydrochloric acid will work.